Dear students, today we are going to discuss the last topic of this chapter, resolving power. Well, what is resolving power? Before we understand it, we need to understand what is diffraction. But this topic, diffraction, we shall be learning in the very next chapter, wave optics. So for the time being, we will have some idea about the diffraction, and then we will try to understand what is resolving power. Well, you see, one behavior of light we will come across in the coming chapters is the dual nature of light, particles, photons. Photons behaves like a particle and behaves like a wave. It is true for all the moving bodies in this universe, but for the case of photons, that is light, it is very vivid, but for other cases it is not so obvious. So we will learn about the dual nature of light. Means it at times it behaves like a matter, like a particle, and at times it behaves like a wave. So there we will also learn two prominent phenomena of the waves, that is interference, when two waves are merging into each other, one wave is superimposed over the another, and another is called diffraction. What happens in diffraction? When light ray is coming across some obstruction, say a sharp edge of a knife, then in that case it bends in the shade area of the knife. This phenomena is known as diffraction. Well, this bending is prominent only when the thickness, the edge of the knife is of the order of wavelength of the light incident on it. And due to this bending of light, we have certain pattern, we get certain pattern, alternately bright and dark pattern is obtained. This is called diffraction, fringe diffraction pattern. We will learn more about it in the next chapter. So now I hope that you got some idea what is diffraction. It is bending of light. Whenever, say, a beam of light is moving and we have a sharp edge over here, then what happens? The light slightly bends into the shaded area. This part, that which was shaded by the knife, light is able to reach that portion also. This phenomena is known as diffraction. Now, due to diffraction we have just discussed, say for example we have a point-like object, then its image will be formed in the form of alternate bright and dark bands. Not a point-like image will be formed, and the central bright is there, followed by dark, alternate dark and bright bands. So the central band, bright band, is known as first maxima, and the immediate next one is known as first minima. Minima means the dark band. In the dark band we don't have any light energy available, and so alternately there is dark and there are dark band and bright bands. Now, when the image of two objects which are very placed close to each other, say for example we are having two pens, they are placed very close to each other, and their image, whatever, say for example we have a device, or we talk about our eye, human eye is also like a device. So if the image of these two formed in our eye, say for example is such that the central maxima of the first image falls on the first minima of the second body's image, as we have drawn over here. Means we are showing it in the waveform over here, brightness and width, etc. So the central maxima is having maximum intensity and maximum brightness, maximum, and gradually it is having alternate dark and bright bands with decreasing intensity and width. So if the first maxima of the image of first body falls on the first minima of the image of second body, then in that case the two bodies are said to be just resolved, means they are clearly visible because they are having different locations for their maxima. Here you can see different locations, means minima of one falls on the maxima of another. Then the two bodies are said to be just resolved, and this is called the limit of resolution. And reciprocal of the limit of resolution, that separation is called limit of resolution. And the reciprocal, you see, the smallest separation between two objects at which they appear just separated is called limit of resolution, and the reciprocal of that is known as resolving power. Reciprocal of limit of resolution, what is the limit, what is the separation, minimum separation for which the image of these two bodies are just resolved, means they are very clearly and distinctly visible, then that separation is known as limit of resolution, and reciprocal of that is known as resolving power. And if the body is having a separation more than the limit of resolution, then that is said to be well resolved. And if the separation is less than the limit of resolution, then it is said to be unresolved. So this is how we define resolving power. It is the reciprocal of limit of resolution. Now we will not have the details of finding resolving power for a compound simple microscope and the telescope or any other device right now, but hopefully in the next chapter we will be doing it and finding the resolving power of the certain devices which we have already discussed. So that's all for today, and we have in this process we have also completed this chapter, ray optics. I hope you have enjoyed it. One thing I will request you all is, please go through the lectures serially and do not skip any of them, because in most of the cases they are highly related and linked. If you don't understand the previous lecture nicely, your understanding of the fresh lectures will become very tough, and that will be a depleting factor for you, and a distraction, disinterest for the subject will be generated. Now you must also realize and accept that our life is totally dictated by the laws of physics in our day-to-day and mechanical life. So you cannot skip learning this subject. Thank you and have a nice day.